Okay, so we will be doing question 7.1 now. Right, so 7.1 telling you that George is placing an even money $100,000 on a bet to where the Bulls will win the NBA Finals. So if the team is winning the NBA Finals, then George will be having $100,000, and if the team is losing, then he will be losing $100,000. Okay, so the question giving you the utility function for George. In terms of the total money, the total amount of money that he's having, which is the total amount of wealth, equal to taking the form of the log of the total amount of wealth. Okay, so his initial amount of money is $1 million. So initially, George is having $1 million. Okay. Now, if he is in the event of winning. Okay, so if he is placing a bet and if he is winning, he will get $100,000. So the total amount, so outside is the total W, which is the total amount of wealth in terms of, so in the event of winning, sorry, will be equal to $1 million plus 100,000, which is equal to 1,100,000. Okay. Now in the event of losing, in the case of loss, the total amount of wealth of George in the case of losing will be equal to his initial amount of money minus the amount of loss, which is 100,000. So he will be having 900,000 in the event of loss. Okay, so the even money gambling mean the person is losing or gaining exactly the same amount of money in the event of winning or losing. Okay, so if he winning, he win $100,000. If he is losing, he will be losing exactly the same amount, $100,000. So that is the even money bet. All right, so now let P be the probability of, say, winning. Okay, so that basically means 1 minus P will be the probability of losing. Alright, so if the person is playing the game, his expected utility will be equal to the probability of winning multiplied by the utility of amount of money in the case of winning, plus 1 minus P, which is the probability of losing, multiplied by the utility in the event of losing, which is the utility of the total amount of money in the case of losing. So we get P. Now the utility function taking the log, and the total amount of money in the case of winning is equal to 1,100,000 plus 1 minus P. The utility is having the log form, and the total amount of money in the case of losing is equal to 900,000. Okay, so if we're using a calculator here, we will find that log of 1,100,000 is equal to A13.9 P plus, so natural log of 900,000 will be equal to 13.7, 1 minus P. And so if I expand everything and then simplify it, I'll get 27.6. Sorry. Just to say I'll expand everything, I get 13.9 P plus 13.7 minus 13.7p, and so I'll get 0.2p plus 13.7. Okay, so that is the expected utility the person can get if he decides to do the gamble. So if he decides to play the game. Now if he not playing the game, so this is the expected utility by playing the game. If the person doesn't play the game, then he will be having $1 million for sure. So he won't be losing anything, but he won't be gaining anything. So he will have $1 million initially, and that will be his total amount wealth. So the utility he can get under the case of no gamble. So this is no. So this is yes. Okay, so under the case of no gamble, he will get the utility, which is the lock of $1 million that he having initially, and this will just equal to 13.8. Okay, so now in order for the player to play the game, okay, or in this case to place a bet, then the expected utility by playing the game will have to be bigger or at least equal to the utility the person could get by not doing anything. Okay, so that is the utility of not playing the game. If this is not the case, then he will never choose to play the game. So in order for the person to be doing the gamble, the expected utility of doing that will have to be bigger or at least equal to the utility of no game. So we have 0.2p plus 13.7 will have to be bigger or equal to 13.8. And therefore, if we're solving this inequality over here, we will get p is bigger or equal to 0.578. Okay, so that is the probability of winning. So the minimum probability of winning will have to be equal to 0.578 in order for the player to be willing to play the game. Okay.